So today we are going to do something really exciting and fun. We are calculating how much, first of all, how much computing one human brain does in flops per second, so floating point operations per second. Then we compute it to the computational power of, say, an A100, an NVIDIA GPU. And then we are going to calculate how much humanity collectively computes in terms of H100, and we calculate the costs of collectively running the computational power. If we wanted to actually create an AI cluster today to calculate as many operations as humanity does. And with this information, we are going to look at the annual cost decline and estimate when collectively it would be cheaper to run AI than to run humanity, basically, or to run the US workforce. So this will be a lot of fun. So let's dive right into it. So I published this article on the Thinkster blog, how much AI compute to match humanity's collective brain compute, a mind-boggling comparison. And we are going to look at this research report from Open Philanthropy, and they basically gave this great graphic here, this chart, where here on this x-axis they show the logarithm of the floating point operations per second, mapping like current computers and the human brain into it. And it's really difficult to estimate the computational power of a human brain. There's no like consensus number, so to say. It is more like a range, right? And you see this range is somewhere from 10 to the power of 11 floating point operations per second and 10 to the power of 18 floating point operations, or even 20. And so in between, like the most reasonable assumption based on this work would be 10 to the power of 15 maybe, or 10 to the power of 12 to 15 or so, right? Would be like the computational power of a single brain. And then as a reference, you have the DGX or NVIDIA A100 computer doing like 10 to the power of 15 or 10 to the power of 16 operations. So it's like orders of magnitude similar to a brain. And the Fugaku supercomputer does like 10 to the power of 17.5 or so flops per second. In the meantime, we have had some significant cost decline. So here in this chart, it gives the cost of a DGX A100 as 200k, but in the meantime it has come down to say 10k or so. So the cost decline was significant since then. We already have the next generation of compute, right? We already have NVIDIA's like for instance like the new Grace Hopper Blackwell chip. We also did a video on the Thinkster channel on the Blackwell infrastructure, so we had significant progress already. But I mean, this gives us like a rough view on how many floating point operations a human brain does. So let's dive into, so here you see the H100 in teraflops. So H100 in teraflops, if you ask ChatGPT, it gives you like a number between, say, here 19 teraflops, sometimes a bit more. So I just want to use different sources to come to a conclusion, but let's maybe dive right into the ChatGPT 4o's estimation. How much computing flops does a human brain do? And it gives, it depends. We have roughly 86 billion neurons and 10,000 synapses per neuron. So we have 860 trillion synapses. These would be the weights in the neural net weights, right? And for as reference, I think the newest ChatGPT 4o model or so, it has maybe 1 trillion or so weights. So it's like in a low trillion scale. So we still have a couple of orders of magnitude more synapses in the human brain than we have on a nicely performing model, AI model, such as ChatGPT 4o. And there are a huge range of estimates, but if we can estimate the human computational power, one human brain's computational power as 8.6 quadrillion operations per second or 8.6 petaflops per second. And if we if you use this 8.6 petaflops per second, we calculate it as like this logarithmic notation to the power of x notation. So we have 1 petaflop is 10 to the power of 15 flops. So 8.6 petaflops would be 8.6 times 10 to the power of 15 flops. Okay, so one human brain has roughly 8.6 to the times 10 to the power of 15 floating point operations per second. Good intermediary result. Now, based on this result, first I want to know like how many NVIDIA A100 GPUs we would need to run this, basically, right? And if we it depends on whether we use single precision, double precision, half precision, tensor operations, and so on. But very roughly, how many A100 GPUs we would need to run one brain? It is like the rough number would be 6.8 or roughly 7. 7 NVIDIA A100 GPUs would be needed to match the estimated computational power of one human brain. So very roughly like almost 10 A100. So let's look at this graphic we have already seen. So here we have the A100 in this arrow, roughly 10 of them. So like one step to the right, we would need to roughly run the human brain. So I think it's a conservative estimation. Maybe 1 would be enough, right? But 10 is likely to be enough. So, and if you have like 7 or so, we are, I think, in a good range. So we need 7 NVIDIA A100 GPUs to have as many operations per second as one human brain. Okay, just 7 A100s. So how much would it cost to run one brain using these assumptions? If we need to differentiate between the hardware cost, the power consumption cost, and the operational cost. So the hardware cost would be the dominant part, right? So it is like you can purchase an A100 GPU for 10K. I basically confirmed this. Once again, here the A100 40 gigabyte costs between 8 and 10K. If you want the 80 gigabit version, it would be a bit more expensive, like 25K. So, okay, but in the orders of 10K just to buy the hardware. And this is interesting. As I said in this paper, they basically give the A100 as the cost of an A100 as 200K. So it has come down significantly. The cost of compute is basically reducing significantly. And we will consider this in our calculations later on. But okay, let's first estimate the cost of running one human brain. So we have 7 A100s and each one costs 10K, so we need to purchase it for 70K. So we pay 70K once and then we can simulate a human brain, right? So pretty good. I mean, we would pay a human brain, we would pay a worker, say 40K to 100K, sometimes 200K per year. And I mean, if we could let it work 24/7, paying 70K would already be a steal, right? It would already be like, in many cases, if you could run a brain exclusively on your business processes and you only pay 70K once and you can run it like for years, it could already be cheaper than just hiring a human to do the work, right? And as for power consumptions, we would need like roughly 2,800 watts and or 2.8 kilowatts. If you pay 10 cents per kilowatt hour, then the cost per hour would be 28 cents. So much cheaper than a human, right? And but this is only for energy, obviously, not for the cost of purchasing the human brain, so to say. And so it's not a hardware cost. The hardware cost, the hardware of purchasing the equivalent of a human brain would be 70K, and then the hourly wage for this hardware would be 28 cents already. And our daily operation cost would be $6 roughly, or annual cost $2,000 per year, so $2,400 per year, which is kind of cheap. So the total cost would be for in a given year 72K. Right, but then in the second year it would come down significantly because you would only pay, say, 2K or so to operate it. With very rough math, I mean, the numbers can be plus minus 10, 20, 30%. Doesn't matter for our calculations here. But let's assume like after 1 year it's maybe completely, we can throw it away or so because next generation hardware comes and so on. Yeah, and hardware next generation is even cheaper and so on. So let's maybe focus only on the first year. So for 1 year it would cost 72k, and then it would become cheaper every single year because we wouldn't have to purchase the hardware anymore. So based on this assumption, what is the cost to run humanity? Yeah, not a single person. So one brain would cost 70,000 to purchase 7 A100s. If you want to run humanity collectively, we would actually need to multiply this with 8 billion, right? Because we have 8 billion people. So so if we go for roughly 70k, we multiply with the global population of 8 billion, we would roughly need 500 trillion. I think the math is right here. The total cost in the first year to replace humanity would be 500 trillion. And then it would become cheaper, right? Because then we would already have the digital brains, the digital computational power. So we could then simply run it at electricity cost. And then we would have to do some replacement over time. Obviously, after very few years, we would have to replace the hardware because it would gradually get disrupted or destroyed, right? So it's it will be used heavily if it runs the whole year. But okay, it's interesting, right? 500 trillion in the first year to basically replace the computational power of humanity. So we can maybe double our research progress or even more, because not all of of humanity are doing research all the time, right? I mean, many do, like implicitly, not maybe for working for academia, but if you are figuring things out, you are contributing to collective knowledge. We are like optimizing our systems, optimizing our knowledge and so on every single day, every single second of our day. We are learning new things and maybe teaching our children and so on. So it's not only about the researchers in academia, it's about the humanity progress, basically. So this would be the cost today, 500 trillion. Which is a significant cost. It's probably more than all assets in the world. Maybe all assets in the world would be like 300 trillion or so, right? But I mean, this cost could still be a very good investment, because obviously having another humanity working 24/7 for us digitally could create a lot of new assets. So it could still be worth it. But I think we are at the cusp. And obviously in the second year it would be much cheaper, right? Because we already could reuse many of the A100s in the second year. We didn't have to purchase them again in the second year, because not all of them would be destroyed after 1 year of operation. So as comparison, what does it mean, 500 trillion? So the annual wages in the US in a given year is 21 trillion, right? So we would have to pay, say, more than 20 times the annual wages for all US workers, 20 times collectively as humanity, to double our brain power today, which is like significant. The world GDP is across like 100 trillion, roughly 100 trillion. So we would have to pay 5 times the annual GDP. So very unrealistic. We wouldn't be able to do it at this cost. So there's nobody, like we cannot spend it. We just cannot obtain the production capacity to do it, right? We don't have enough money, we don't have enough wealth or production capacity yet. We would have to actually tap into AI itself to produce such a huge work. But we are on the way, right? We are doing it, and you can see the value proposition. It would be insane. Nobody could imagine what would happen if you would double our brain power and channel the brain power maybe in new research and improvements, and introducing efficiencies. It would be it will be a completely different world, and it's already kind of doable. It would be a very stretched goal over time, but even if the cost wouldn't decline, the cost for AI training, it would be doable over a long period of time, right? As we maybe we don't spend 500 trillion, maybe we spend 1 trillion or 2 trillion or so in 2024, and then we have additional productive capacity from the AIs, from the 2 trillion worth of AIs, brain power, and we can then use it and reuse it and rechannel the productive capacity into the economy. So maybe in the next year spend 4 trillion, 8 trillion, and over time we would maybe make it to 500 trillion or even more, even if we didn't reduce AI training costs over time. However, if we consider the annual cost decline of AI training, that is roughly 70% per year, according to ARK Invest and different other researchers. And maybe let's not go with 70% cost decline. So the cost to run one floating point operation basically for AI training and AI inference, it has declined by 70% per year. But maybe let's not go with a 70% assumption. Let's maybe go with the 50% per year assumption. So would an annual decline of AI training costs of 50% per year be reasonable between 2024 and 2030? If yes, calculate the cost of running humanity for every year from 2024 to 2030. So 50% annual cost decline is reasonable based on historical trends. And if you calculate the cost of running humanity now for each year under this assumption of having this 50% annual cost decline, things look very, very, very bullish for AI and humanity as well, right? So the annual decline would be 50%. We start with 500 trillion in today's in today's dollar, right? In 2024, cost of duplicating humanity. Now, if we apply the 50% reduction, we basically in the second year get 250 trillion cost to pull this off, then 128 trillion cost, and so on, right? To only $8 trillion cost in 2030. So if we plot this, we basically get this chart here, this beautiful chart, where we have over the years in yellow, we show the AI training costs to run humanity digitally, like all human brains. The collective brain power. I mean, I'm not talking about literally running the human brains in the cloud. I'm talking about running the equivalent brain power of humanity in AI data centers or AI factories, as NVIDIA calls it. If we actually do this, they are just doing work just like us, workers, employees, right? Just like us. Maybe business owners and so on. AI can also create businesses, digital businesses, or even later on physical businesses using robotics and embodied AI. And so we can run real businesses. We can do real competitions in the digital realm, or in the, I should say, computing, artificial brain, artificial AI realm. And we can do research, discover new things, discover new materials, discover new energy sources, harness energy using like manual labor. So AI can also do manual labor, right, through robotics and embodied AI and so on. So collectively, like duplicating the computational effort of humanity's collective brain power would cost us less than the US workforce, here in the red dashed line, in the year 2028. So in only 4 short years, it will be cheaper to run AI, an AI equivalent to humanity's collective brain power, than to pay only the US workforce, right? So we can basically, if a few companies like the US does it, we could actually host, say, 5 times the computational power of humanity, using the cost of only 5 times the US workforce in a few short years. And obviously, I mean, the leverage we would obtain with duplicating all of our collective computational power would be insane. I mean, this is the brain, our collective brain power is what put us here. What put us to this situation, to this day and age where humanity basically dominates the planet, and I mean, this is kind of, we are talking about domination of kind of the galaxy, right? It's like total, the intelligence explosion that is currently happening is insane, and we are at the cusp, like in this decade, in a few short years, we will see how AI will collectively have more computational power than collectively all human brains, which is insane, right? We are still away from this reality. It's still not there. We are several orders of magnitude away from this reality, but it will happen very soon because the cost will be just so cheap, and everything will change as a result. And that's why I created the Thinkster channel and the Thinkster. I started making the daily videos and so on, and I created the new Thinkster slogan, be on the right side of change, because in this decade everything will change. Schools will be completely unnecessary in a way, right? I mean, at least the traditional way of learning in schools, like having a class system and so on, maybe getting taught by a human being in some rudimentary basic knowledge areas, right? So like teaching Latin or teaching language or so, very traditionalist with learning vocabulary and so on. So I mean, all of this will change. Everything will be completely unnecessary. I mean, we can still do it, but it will be completely unnecessary to teach human brains, slow human brains, to spend 20 years teaching them these kind of things, right? In a very slow and laborious way. It is completely unnecessary. It's much too expensive, and we would rather simply run AI in data centers and do the work for us. And of course, this will then unlock humanity's brain power once more after like several industrial and agrarian revolutions we have had over the centuries. This will once more release a lot of human energy, and I mean human brain energy, collective energy, that must be channeled into new areas. Maybe having more children, maybe spending more time with your loved ones, maybe like doing all the kind of things you want to do. I mean, these are the hopeful. This is a hopeful view. Of course, you can also have like a depressing view on the future, but I think it's a huge opportunity, and we are seeing here like black and white in ink what will happen with the future. I mean, if you look at this chart, it shows you it shows you the future. It shows you I mean, this chart, everything you need to know is encoded in this chart. If you ask yourself questions like, maybe should I go to university, spend 5 years there? I mean, as you leave university, maybe 5 years later, so if you join university now in 2024, 5 years later, 2029, here we are at this point in time, right? Where just doubling the brain power of humanity would be cheaper than just running the US workforce. And humanity is much larger than the US workforce, right? And the US workforce in many ways isn't used productively, right? Many of them just say drink coffee and talk and chat and so on, right? I mean, or sleep. And this brain, this digital equivalent of humanity, can run forever, can run 24/7, and can produce stuff for us. So it's like going to university. I mean, it could be a good investment in terms of meeting new people, but maybe that's the only thing, that's the only benefit you can obtain from going to university. It's not about the knowledge you learn there. The knowledge you learn there is basically useless. I mean, what will be useful, I think, will be skills we teach at the academy. I hope so, such as using like different APIs and AI APIs to create value in the real world and to integrate AI into business systems in the real world, because I think this will be the bottleneck in a way to now use this potential, this power we have in the data centers, and plug it into the real world to power the real world with intelligence everywhere. And these are the skills maybe you can teach at university, or just go to Thinkster University, Thinkster Academy, which will be orders of magnitude cheaper. Here, how to build multi-agent teams and systems with LangGraph and so on. So I mean, these kind of skills will be very useful in this decade. This I'm very sure of. Then of course, I mean, in the 2030s, everything can happen if you really duplicate humanity. I mean, whatever. I mean, your prediction is as good as mine. Okay, but I thought this would be very interesting to project when AI running an artificial humanity would be cheaper than running just the US workforce, and it's really interesting. My prediction is on the year 2028 based on this quick napkin math. Thanks for watching. Please give me a like and subscribe to the channel if you like this kind of stuff, and see you in the next video. Bye.